Alright guys, episode 32, here we are. Welcome back to Home Theater Gurus. So let's go ahead and get into our laptop and start designing our sub. I'm not sure what the name's going to be. I'm still waiting on all the comments to, for you guys to come up with names. Who knows what it's going to be, but we're going to name it and claim it. So let's get on the laptop. Okay, so we've got our laptop open. And let's go to our browser. Now we're going to do a search for WinISD. Okay, when we do that, it's going to bring us, the first hit is linearteam.org. Now, this is going to be the latest version right here, and we've got some older versions down here. The latest version sucks as far as I'm concerned. I do not like the layout at all. It's just not easy on your eyes. It's let's look at it real quick. So this is it right here. And I just don't like it. It's hard to see for me. It doesn't pop. I'm not sure why they went with this look. I mean, it's a huge downgrade in my opinion, just the overall look of it. So we're going to use a little bit older version. Now, it may be older, but it works just as well. I've compared the data. It's, there's no difference. You're going to get the same results using either one. So we're going to do a search for WinISD Pro. Now you can use either one, use whichever version you want to. It doesn't really matter. It's just what I prefer. Now, of course, here is the website, the linearteam.org. It's not on there. It's just showing up because we searched WinISD. You're going to have to go to one of these other ones. These are just some download sites. This one right here, softpedia.com. I did a search on it. It's a legit website to to download stuff. And just click on free download. Click one. And there it is. WinISD alpha.exe. I'm not going to install it because I've already installed it. And there it is right there. Already installed. So once you install it, you're going to open it up. And let's go ahead and maximize it. And I mean, as you see, it's just much nicer. I like the colors. I don't know. I just like it. Much easier for me to use. All right, so let's go ahead and load a driver. It's the first thing we have to do is we've got to get the driver's data or parameters in WinISD so we can do some modeling. So let's go in here and let's do one for, let's do Dayton UM18. Let's go ahead and see how this models real quick. All right, so there it is. Now, the parameters and stuff, they're down here like on Parts Express website, but just in case something's not accurate, we can click up here and get it straight from Dayton. Here's the specs, and there we go. All right, so we're going to minimize this, and what we're going to need is this information right here. Let's go ahead and get it to take up that window. Okay, and I'll show you one other thing. Before we do that, there's a certain order you have to enter the data into WinISD. So let's go ahead and do WinISD tutorial. Now the first one right here, this is the one I like, Midwest Audio Club. It's just real easy to see the, the order. You just scroll down here. This tells you a little bit about WinISD, actually a lot about it. But what we need is the order to enter the parameters. And here they are. All right, so we want this on one side and we want WinISD on the other. So let's go ahead and minimize this window so we can get them side by side. All right, there we go. We're going to hit New Project. And we're going to hit New. Okay, we don't have to fill out any information right here. Just don't worry about that. Go ahead and go to Parameters. Now, this order, like I said, you have to enter all this stuff in order. If you don't, WinISD flips out, freaks out. It'll throw all kind of errors. And a lot of people give up on it because they can't get the drivers loaded correctly. And so sometimes even if they do get past this screen, the information that they're modeling is not correct. So if you don't put it in the right order, things won't work. It flips out, and that's aggravating. So but we know the order, and so first we're going to enter the DD or SD. And so here's our SD right here. It's 1219 centimeters squared. So let's go ahead and find it. SD is right here. And you see right here it says centimeter squared. We can select different measurements. Of course, we need centimeters squared because that's how our parameters are given to us in this instance. And we had 1219. So let's enter it, hit the enter button. Okay, and then after that, RE, which is right above it in ohms. And we look over on our right, and 4.4. Okay, 4.4 ohms. All right, and then we're going to need QES, and QES is up here. And let's see, QES, there we go. QES is right here, 0.62. 0.62, enter. Then after QES is QMS, it's right here. QMS is 3.82. All right, now you notice some of the stuff is populating over here in blue because we have it checked. Here we go, auto calculate unknowns. This needs to be checked. It's going to automatically fill in some of the data for you. All right, so we just did QMS. Now we're going to do VAS, and VAS is right here, and you notice it's in cubic feet. So VAS right here, it's in liters, so we need to change it. Liters, there we go. All right, and that was VAS, 212 liters. Okay, hit enter. Okay, then we need to do FS. FS is up here in hertz, and that's 19.5. All right, and then Xmax. All right, Xmax. Here we go, right here, 22 millimeters. And again, millimeters, we're okay there. So 22. All right, let's hit save. All of our data's in there. That's all we really have to put in. Notice, you know, a lot of blue here, so a lot's been populated for us. Of course, if you wanted to, you know, it's got 2 voice coils, and you know, but that's not gonna matter really for our modeling purposes. All right, so I name everything I enter with the letter A, so it pops up first in the list. So I'm gonna put A Dayton UM18. All right, let's go ahead and maximize this. Let's go find it. We're going to hit right here our drop down. So, and you'll see I have a Dayton this, a Dayton that. I put an A in front of everything so it's at the top so I can easily find the drivers I want to work on. UM18. Let's go with a ported or vented alignment. You'll see a little picture of it right there. Chevy Chev style. I don't know if I'm saying that right, but that's the one you select. Okay. Now when it finishes or loads up, it's going to give you, you know, a sort of a optimal enclosure size. But if we look over here at box, it's 21 cubic feet, so that's way too big. So first thing we need to do is we need to start, you know, thinking about how big our enclosure can be, you know, how many cubic feet. And if it's not in cubic feet, you know, you can hit this right here. Like sometimes it may be in liters, you know, or if you need to convert, if you're following someone else's size, you know, and they say, well, my box is this big, you can come in here, you know, enter their liters and then convert it to cubic feet. And I like working in cubic feet. So anyway, let's say we try a 16 cube box, which is still a huge box. Now, let's look at this response right here. We can click on the tile, and then our line is going to follow that white line, or the response that we're working with. And you see it where our white line is at 26.56 hertz, and we've got, you see where it says 0.118 dB. That means it's slightly above baseline. And you see baseline here is the red line. The purple line here, that's the -3 point. This is how speakers and subs, you know, they're all rated with a plus or minus -3. So when you look at a specification of a subwoofer, you know, in an enclosure, a manufacturer, they're usually going to spec it to the -3, like it may have extension or a -3 point of 18 hertz. That means at 18 hertz, it's going to be hitting this purple line. That's not in room. In room, you're going to extend a little bit lower, or you should, unless it's a a big huge room. But anyway, so that's what that is. It's just helping us design our subwoofer, and that -3 point is already labeled for us with that purple line. So anyway, this is a nice looking response. I mean, our -3 point, and we're down to like around 13 hertz. I mean, that's great. This is a huge box. 16 cubes is really big. So let's go ahead and go down to, let's try 11. All right, 11 cubes. Now that's about the same size as what a full Marty. I think it's 11 cubes. But the tuning, let's watch and see what the tuning does when we alter the tuning. Right now it's tuned for 14 hertz. Let's raise it. Let's raise it to 20 hertz. All right, see, it caused a peak right here. And if we look, see, remember, red is our baseline. We're at 3.23 dB, so about 3 dB above the baseline. Now in a room, you're going to have even more output here because of room gain, but then you're going to come back and EQ, so all of this extra output above your baseline is going to be headroom. And then you're also going to have a house curve. You're going to usually EQ in your response, or you're going to be using a loudness compensator like dynamic EQ. Yamaha also has a version of loudness compensation as well, and so they're going to integrate their own house curve into the subs, and it's going to be more boosting the further you are from reference. So this peak right here would actually be helpful because it's extra output, in those areas where, you're going to want a little more output anyway. But let's see. We come back to baseline around 18.7 hertz. Our -3 is around 16. Well, let's see what we can do. Let's drop our tuning a little bit. Let's go ahead and drop it to 17 hertz. All right, now look at that. That -3 is down to 15. Our baseline, we come back to baseline around 19. That's just a really nice looking response. And this is a full Marty right here. So, that's pretty much all they did was they looked at a few different boxes. I think the mini Marty, or the next size down from the full, the 9 cubic foot box. So you see it still has a nice response. And the tuning might be a 1 hertz higher. I think it's like 18 hertz. But it's not quite as good as the full Marty. You see, let's look at, reaches baseline at 21 hertz, and if we go back to 11 cubes, we're extending a little bit lower. So they're both going to sound really, really good. But anyway, that's how the full Marty was designed. All right, so now that we've done that, let's go ahead and work with the driver we're going to be messing with, because I want to use a UM12 because we want something that's a little smaller, can fit in the living room, pretty easily, and can use a much smaller box. Because as you see, well, let's just look real quick. If we try to use something like a 5 cube box, I mean, look at that response. We can tune it higher, and that's not looking good. That was 30. I didn't mean to do 30. 25. That's not looking good. 20 hertz. So I mean, it's not going to work well in a small box. I mean, we're not getting any low extension. Our -3 is at 21 for a -3. I mean, that's not good. We're crossing, getting below baseline at 26. So the UM18 is just not going to work well in a smaller box. All right, let's look at a sealed box real quick just to compare. Let's use the same driver, UM18. Okay, it's already set up for closed. Okay. All right. Now, if you notice right here with the seal, this QTC, you may have heard that before. You want that around a 0.7. And when we change the box size, it's going to change that, but also stuffing changes it as well. So a lot of times, like if you look at Parts Express, it'll say to use like a 4 cubic foot box and give it, I think 3 or 4 pounds of stuffing. It tells you how much stuffing to put in there, and it's going to bring the QTC back up to around a 0.7, which is optimal. And if you change that QTC, or it can be a little sloppier or not as tight. I mean, it's kind of like tuning the sound of the sub. And we can look at how it changes by changing the box size here. Let's go to a 4. Now, of course, this has no stuffing. See, now we're at 0.89, but our response doesn't look as good. So let's go with the 8 and see how we're getting a little more output down low. It's just changing the slope a little bit. It's going to change the sound a little bit. Well, let's compare it to a full Marty. And you see the full Marty has a lot more output on, very, very little power. Right here at 20 hertz, let's just click on this yellow one so it'll follow the yellow line. At 20 hertz, we're negative 6.5 dB. So we're way below our red line, and that full Marty is what, half a dB above it. So 7 dB. So every 3 dB we need double the power. So I mean, we're looking at what, 2 times, 4 times, just over 4 times the power to get this yellow line, to get this sealed sub to output what that ported sub is doing. So the ported sub can sip power, where the yellow one you're going to really have to force feed it some power. And often this is why you see more sealed subs in a room, if you're trying to hit reference, especially down low. But let's look at something real quick. When you buy a sealed sub, or you buy subs, or really any subs from a manufacturer, they're usually in a box that's a little too small, not quite designed optimally. That's why DIY subs are usually bigger, but they're going to have baked in EQ. So what that does is, let's see what it does to this, our yellow sealed sub here. Alright, you see what that did, how it lifted it up? Alright, so let's try a different filter to add another link width transformer. Let's go to 15. Alright, let's get rid of that one. Alright, so you see if we apply this filter to it, we've actually got a nice response. But if you notice, at 15 hertz, the sealed sub is slowly dropping, where the ported sub drops, kind of like a rock. So this is where the sealed subs have, a kind of advantage, because they extend a little bit lower, but you see you're using a lot more power. So I mean, at this point, with this filter that we applied, at 20 hertz, remember how far down we were. See, we're really doing some major boosting to get that response back up. So sealed subs are good, but they just require more power. So it depends on the kind of room. If you're in a really large open room and you want the maximum, the most output, you can go with something like a UM12 and get some really, really good output, if it's in a ported alignment. But if you want to go, as low as possible, you may want to do sealed. And but you're going to need a lot more power, and you may need more drivers to pull it off. So anyway, enough about that. Let's go ahead and start designing our sub. Alright, so we're going to be doing a UM12. New project. Previous. Okay, so again, it's going to give like an optimal size enclosure, but that's still pretty big. Let's go ahead and change that color real quick. You just click on the little bar next to parameters and we can change it. Let's go to blue. Hopefully y'all can see that really well. Alright, so let's go with something a little better. Let's see how it looks in a 3Q box. Alright, now we still need to mess with our tuning a little bit. Just because it's in a small box, right now it doesn't look good with the tuning it had. Let's see what we can do with it. Let's go with 20 hertz. Oh, let's see, already it's looking really good. I mean, we're just down 2 dB at 20 hertz. Our negative 3 point is around 17 hertz. Just this right here is actually a really good sub. So, and we're going to look here in a few minutes. We're going to look at like an SVS PV13, and we're going to look at its frequency responses and see how it kind of compares to what we're doing here. And remember, they're using EQ, or this baked in boosting, depending on what tuning you're using. That they're using that to get the response, and we're not using anything right here. This is a raw response with no EQ. This is just how it looks in that enclosure we just made. All right, so now, so we can compare one enclosure to another, let's go ahead and open another project with the same driver. All right, let's go with a different color. Let's see, yellow should pop. Yeah, you can see that. All right. Now you see even that huge box, I mean, it does extend a little bit lower, but I mean, our box is still looking pretty good even at 3 cubes. Let's try 3.5. And we don't want to go too big because we're trying to keep this as small as possible and get a good response. Let's try 19 hertz. So look at there. See, that looks really good. Now, if you remember back from the mid-bass slam episode, you know, we're going to have a lot of kick up in this area right here in this 30 to 60 hertz range. You know, a lot of peaks and a lot of that mid-bass that we want, or that people mistakenly call mid-bass. And if you haven't seen that episode, you might want to go back and watch it, where we take actual measurements of a few popular scenes, you know, where people talk about, you know, this has a lot of mid-bass kick, and we're actually looking at where that's happening at frequency-wise. So anyway, you know, it's good to have a little bit of a rise in that area, and plus when we stick this in room, we're going to have even more, you know, help down here. Let's see. Let's go ahead and see if we can tune it for 18 hertz. I mean, that looks good as well. You know, even though it's dropping, you know, below our baseline is right here around 30 hertz. It begins to drop below it, but I mean, even we're only down 2 dB, or not even quite 2 dB at 20 hertz. So I mean, that's really going to be a really good performing sub. Let's go with 18.5. And the only reason I know 18.5 is because I've gone ahead, and that's going to work well on the next episode whenever we go to actually design our enclosure. So let's check a few things out. Let's look at our vent. All right, now I want to point out, you can change any of these parameters, like inches. Just go over to it, and you know, you click it, convert it to feet, yards, meters, millimeters. Of course, I'm working with inches, and as it converted, you see it's off a little bit, so just have to change it back to what we had it at. But you know, the same thing over here on vent length. If you want it in feet, yards, whatever. So if it's not in the measurement you want it in, you can just put your little finger over it and change it very easily with the left click. Alright, so let's click on the vent tab right here. We can look at our vent. We can change it. See, it's defaulted to a round port. Let's go ahead and go with a slot port for this build. Now, vent diameter. Now, I already know what it needs to be because, like I said, I've gone ahead, but we're going to go with a 1.25 vent, and we need it to be 15.5 inches wide. Like I said, I've already gone ahead, so that's how I know what it needs to be. So now okay, right here we've got our length. We just put those numbers in. Now you notice if we go to like a 15-inch vent, see how the inches changes right here, and we're going to go back with a 15.5, and they're going to change again. So our vent, or the mouth of our vent or our port, is going to change our vent length. Now let's look at what happens. Let's say we're doing this vent length, and you know, we're off a little bit. It was 39.7 or whatever. Let's say we cut it 36. All right, I mean, look at our response. Our response still looks good. Let's look at the box and see what it did. Now we had an 18.5 tuning frequency. It raised our tuning a little bit, but it's still a good response. All right, so let's go back to 18.5. Now that was if we cut it too short. Let's say it's too long. We got 39.7. Let's say it's 42. I mean, look at our response. The response still looks good. Let's see what it did to our tuning. So now our tuning is 18.04 instead of 18.5. So the moral of that story is, if your vent is a little off, don't stress over it. You know, an inch here or there is not going to matter, especially like this vent is 30-something inches long. Now, you know, you want to try to get it as close as possible. You know, I mean, don't shoot for 3 or 4 inches off, but, you know, shoot to have it perfect. And if it's a little off here or there, it's no big deal. Same thing with the box size. You know, let's look, you know, you have your displacement of the driver and the ports inside the enclosure. You know, this 3.5 cubic feet, that's what the driver sees. So you have to deduct the port, you know, displacement, the driver displacement, you know, the bracing displacement, which bracing is not going to be much. I mean, the driver's not going to be much either. Usually, you know, the port is going to be what displaces the most volume. So let's say you're a quarter of a cubic foot off in this, which is going to be a lot. I mean, you're not going to be that far off. But let's say 3.25. You still have a good response. Let's say you're, you know, it's 3.75. You're you displace too much in your calculations, and the box, that still looks good. It looks even better. So with your port length and your box volume, you need to be close, but it doesn't have to be perfect. Shoot for perfect, but don't stress over it. It's not even really going to be audible if you're, a quarter of a cubic foot, either way, not at least on this sub. Or, a larger sub, it'll matter even less. But now, if you get to where you're messing with a 1 cubic box, say a UM12 that does well, UM10 that does well on a 1 cubic foot box, there a quarter of a cube is going to make more of a difference because it's, a greater percentage of the enclosure volume. So, all right, a few other things we need to check. So we know we want our response to look like this. All right, but we have to look at cone excursion. It's one thing we need to look at, so let's go ahead and check that out. So right now, our sub has no power applied to it. So let's go to signal. Let's give it 600 watts. And I believe, if I'm not mistaken, that's what this is rated at, this UM12, ORMS 600 watts. It's going to be a lot of power. It's in a ported box, so it's not going to need a lot of juice. We're not having to push it like a sealed sub where we're having to force feed it power. It's going to be easy to drive. So, you can go with even a somewhat inexpensive plate amp and drive this thing. It's going to be easy to drive, and it's not going to cost you a fortune to drive it. So our tuning frequency is going to be around here. We're at 18.5. You see that's where that dip is. Now you notice, okay, this is cone movement. Our cone is not really moving that much at tuning frequency. And this is where the port is going to have the most air coming through it. So at tuning frequency, you're going to notice the driver's not moving as much, but there's going to be a lot of air coming through the port. Half an octave above that, we're going to have an excursion peak. So right around over here at 27, 28 hertz, we have an excursion peak. The driver's really going to be moving at this frequency. So if you watch, if we apply 800 watts, we're going to exceed X max. And here, we are at 21 millimeters. And 19 millimeters is what this driver was spec'd at for X max. Of course, the UM12s it's known that Dayton does underspec these, so they will actually outperform their specs somewhat. So this driver would actually be fine on 800 watts, but we're going to go ahead and stay within the limits we're given, 600 watts. So now that we've applied power, and we kind of have an idea of what we can give it. Okay, we know that right around here, we're going to begin exceeding X max and see losing cone control. It's just going off the charts. So we're going to have to place a filter up in here. So we're going to use our MiniDSP, hopefully we're using something like that to apply your high pass filter, because we don't want this to happen right here. And once you do that, you're protecting your driver, and this is what you're protecting it from, and you're good to go and don't have to worry about it. If you don't apply it, this is going to happen. A low note's going to hit. Edge of Tomorrow, the intro scene that's killed so many subs. If you're not protected, you're asking for it. So, use a filter. All right, so now we need to look at air velocity. So you're going to go to rear port air velocity. All right, so this tab is a really important tab, and it can really separate a poor design from a good design. And we're all familiar with port chuffing. Even subs like, SVS, PB16 even, these very expensive subs are known to chuff. And the reason is because of this air velocity. And this right here is a measurement of how much air we have moving through the port at different frequencies. Now, you see we can click on it here and let 30 hertz. We've got 8.17 meters a second passing through the port. Now this is at 600 watts, so this is full tilt. We're really hammering on it pretty good, but we want to make sure that our sub is not going to chuff at any point, especially if we have to boost anywhere. Because if you have to boost here at 30 hertz, you're going to have even more than 8.1 meters a second going through the port. But of course, we're hopefully not going to go over our 600 watts. But anyway, so we need to look at this peak right here. Now this is going to be around tuning, where we have the max amount of airflow through the port, and we've got at 16 hertz 33 meters a second going through this port. Now that's about your limit. You really don't want to go over 30 if you don't have to. Now, at 30 and below, you can aim the ports to you and you're not going to hear them chuff, as long as you stay within your power limits. Now, rear ported, you can go a little bit higher than that. I mean, front ported, you can go higher than that too, really. I mean, I've gone up to 50 and I still don't have any problems, but it's because I put, a filter on it. So if I put a filter on this one at say 16 or 17 hertz, I'm going to start sloping off here. I'm never going to get, quite at that peak air velocity. I'm going to start cutting it short before it gets there. But, it's just a good rule of thumb. 30, 30-ish, low 30s is a good target to not exceed. So, but, as far as internet direct subs or like, branded subs, you have to remember they have to be able to ship these things. So it's a fight or a compromises they have to make. They have to keep the enclosure small, and the larger ports that it takes to get this velocity down requires larger cabinets because it eats up internal volume. And speaking of that, let's take a look at our port. There's things we could do to lower this even more. Let's say we could go with 2 ports. But before we do that, let's look at our length, 39 inches for 1 port. If we were to go with 2, our velocity, I mean, it just crashes down, 16.6 meters a second. So awesome. I mean, just really good port velocity. But now we've got 2 83-inch long ports. So you can imagine how much larger this enclosure now has to be to accommodate that extra port and the extra length added to each port. So, I mean, that's just not something we want to do. And the same thing, let's just go with round. For an example, let's say we have a 4-inch port. Okay, 1 4-inch port. And we've got velocity of 50.744. Now, this is a little bit high, especially if it's, a front-facing port. You can put a flare on it. That'll help. So you probably wouldn't have any issues or problems, but, you're getting to the danger zone here. So it would be best to go a little larger. Now, if you can go with a 5, of course, it's going to drop it way down. But now you've got a 5-inch port that's 40 inches long. When we had the 4-inch port, okay, see everything dropped out. We need to go back to box and put our tuning back. It does that sometimes. So if you see it, you know what it is. Just go to put your tuning back in. So the 4-inch port was 25 inches. So you see how much more, volume it takes up to go with a larger port. You can go with a smaller port and you need a less length and it's less diameter displacement, so it's taking up much less volume. So this is kind of a struggle that sub manufacturers have to do because they have to keep these things shippable, and we have to do the same. We don't want anything that's just got tons of port displacement inside, and we want to keep it small as well, but we're kind of aiming more towards performance because we can afford to go a little bit bigger. We're not having to ship it. So anyway, we're going to go back to 1.25 and 15.5, and again we lost our tuning. 18.5, there we go. All right, so and that's how we adjust our velocity here. Now we could also go with a little bit, say a taller port, 1.5. See, now that drops it down. We were just over, 33-ish. Now we're at 28. But like I said, I've already run the calculations, and this is what I'm going to go with. And you'll see on the next episode how it's all going to fit. And I try to make it to where the panels are easier to cut with even numbers and stuff like that for guys that want to replicate this build. All right, so now real quick, let's go ahead and compare what we have to something like a PB13. All right, so if we go to the PB13 website, we see down here there's their plus and minus -3. So they're basically saying in the 20 hertz mode, which if we look up here is purple, this line right here, they're claiming a -3 at 17 hertz. All right, so if we look right here, their baseline is right at 90 dB. So 87 dB is going to be right around here. And let's say it's right there. And I'm going to say that's around 21 hertz. They're claiming 17. 17 is down here. And I'd say they're around a -7 at 17, somewhere around there. They don't put any, it make it kind of hard to read this graph, but this is not matching up with that. But remember, so if this is a -3 of around 20, what was our -3 real quick? Our -3, we'll say 17. It's actually 16.7. We're going to call it 17 for ours. Alright, now their 16 hertz mode, which is green. Let's see what their -3 is. Alright, so I'm going to say the 16 hertz tune, it's probably around 87 for a baseline. So where's 80, what is that, 84? Just right around here. Maybe 17 hertz, and they're claiming a negative, or they're claiming a 14 dB for 16 hertz. Now 14 dB is like here, and that's down. I'd say that's about a -7. So I mean they're skewing their numbers a little bit, but they all do that. With all of these, you have to plug the ports, and then you have to tell it, go into the the plate amp, and you have to tell it what ports are plugged, so it knows what setting you're in, and it's going to apply boosting to get these responses. So the PB13 is a very popular sub, and I would not be surprised if our sub here actually does very well, comparable to something like that. And we'll take this sub right here and we'll run some compression test on it, and we'll test it against the database measurements of like a PB13 just to see how it compares. So alright guys, that's going to be it for this one. On the next episode, we're going to take this information and we're going to plug it into an online app that kind of does a little 3D model of our subwoofer, and we can kind of see how it's going to look and get the dimensions we want, and from there we can build it. And it'll also give us dimensions, a cut sheet, and it's a pretty slick little program I found. Some of you may already know about it, or I've used some online programs similar, but I've always done this by hand. But I figure for this, this little tutorial, we'll go ahead and I found something a little better that's easier for everybody to use. Alright guys, so that's going to be it for this one. Don't forget to subscribe, hit the notification bell so you know when the next episodes come out. And I'll see y'all next time where we start to actually design the look of our sub. See you later.